In this example, we'll be graphing this transformed exponential function. But before we do so, we're going to graph the original function. And the original function was y equals 2 to the power of x. I've gone ahead and I've already created a table of values for that original function. So let's go and graph it. So over here, we begin at 0 and 1, 1 and 2, 2 and 4, 3 and 8. You can keep going, but I'm just going to leave it like so. Let's connect these dots. So your exponential function should look something like that. Now, from before, we know that there is a reflection in the y-axis. So that means we can strike these items out since they're not applicable. Okay, so when you are reflecting something in the y-axis, the x-coordinates change. And you're going to multiply this by -1. So 0 stays the same, 1 becomes -1, 2 becomes -2, 3 becomes -3, 4 becomes -4. Okay, so these are going to be your new x coordinates, and your y coordinates are going to remain the same. So let's go ahead and graph that up here. So 0 and 1 stays exactly the same. We next have -1, +2, -2, +4, -3, +8. So let's go ahead and connect those dots. And there you go. We have a graph of the transformed function. And as you can see, it has been reflected in the y-axis. Let's determine some of its properties. So for the domain is x is an element of the real numbers. As you can see, that doesn't change. It is the same. In terms of the range, you can see that y has to be greater than 0. So let's write that down. And again, that's related to the horizontal asymptote. There are no x-intercepts, so let's cross that out. There is a y-intercept. The y-intercept is the same. The y-intercept is +1. So let's go ahead and write that as +1. For the interval of increase or decrease, that changes. So as x increases, y decreases. So you can say it is decreasing. Now for the horizontal asymptote was originally right over here. And it had an equation of y equals 0. Because the function was reflected in the y-axis, it doesn't really change anything. So that means the horizontal asymptote